Welcome back to Rohini College of Engineering and Technology video lecture series. I am Professor Radhika from Chemistry Department. In this module, we discuss about the external conditioning methods. So we know that conditioning is nothing but the process of removing hardness causing salts. So conditioning is classified into two types, one is internal conditioning and external conditioning. In the next module, we will discuss about the internal conditioning. Now we discuss about external conditioning. So external conditioning involves the removal of hardness causing salts from the water before used in the boiler. So this process is done by demineralization or ion exchange process, zeolite, which is otherwise known as a permuted process, and lime soda process. So demineralization process is carried out with the help of demineralizer, which consists of two compartments. One is cationic compartment and another one is the anionic compartment. Both compartments are connected with the insoluble cross-linked long-chain organic polymers with microporous structures. So these resins are responsible for these resins connected with the functional groups are responsible for ion exchanging properties. So the cationic exchange resin, which is present in the left column, which is connected with the acidic functional groups like COOH, SO3H, which can replace the H plus ions with other cations present in the hot water. Normally, it can represent as RH or RH2. The examples of cationic resins are sulfonated coal, sulfonated polystyrene, and phenol formaldehyde resin. Similarly, the anionic resins are connected with acidic basic functional groups like NH2 hydroxide groups, which can be represented as ROH or ROH twice. The examples of anionic exchange resins are methyl ammonium hydroxysterine, cross-linked quaternary ammonium salt, as well as urea formaldehyde resin. Let us discuss about the process of demineralization. So initially, the hot water, which consists of the salts, which is passed into the cationic resin column. So the cationic resin column exchange the cations present in the hard water. So it removes the cations present in the water, and the remaining water is passed into the anionic resin column. So the cationic resin is represented as RH2, our water containing calcium chloride salt. So when we pass the water into cationic resin, that resins exchange the cations with cation present in the water. Therefore, we have the resin connected with calcium. Then the remaining anion is passed into the anionic column. So this is a demineralizer instrument which consists of two compartments. So the remaining water is passed into the anionic column, which absorbing the anions present in the water. So now our water containing the chloride ion, that chloride ion is passed in the resin, which exchanging the anions. Therefore, the chloride ion is exchanged by the anionic resin. Finally, we get the water. That water doesn't have any kind of cations or anions. So that water is called as a demineralized water or deionized water. So when we do the process continuously, the resins becomes exhausted. So it is purified with the help of chemicals like NaOH as well as hydrochloric acids. The cationic resin is regenerated with the help of acids by using HCl or H2SO4. We can once again regenerate the cationic resin, that is RH2. Similarly, the anionic resin is regenerated with the help of using sodium hydroxide. So here also the same ion exchanger process takes place. Finally, we get the basic resin or NOOH twice. So this method having some advantages. This method produces soft water which having very low hardness. Highly acidic as well as alkaline water can be treated by this method. The regeneration of ion exchange resin is possible. And the maintenance cost also very less. The disposal problem of sludge is somewhat very less. So this topic, after the completion of this topic, students can able to know how the minerals are removed by this method, as well as how we obtain the zero hardness water. What about the conductivity reduction of water, and how the water is used in the boiler feed water treatments, cooling water treatments, and water treatment processes. Similarly, this method also having some outcomes, that is the reduction of chemical use, wastewater reduction, and the reducing the maintenance cost, increased equipment life, improved product quality. So these are the outcomes which learn about the learn by the students after discuss about this demineralization process. This disadvantages of ion exchange processes. This is the equipment cost is somewhat high. The high turbid water cannot be treated by this method, and also the expensive chemicals are also required. Thank you.